Hello, everybody. Good afternoon here in Europe and good morning there in USA. Thank you very much for joining us today. We are so excited to have the opportunity to celebrate our second webinar at Openvia. And on this occasion is focused on roads, future of roads. But first of all, I would like to introduce myself. I am Isabel Fernández. I am the marketing manager of Openvia, and I will be leading the session today. One very important thing is that we are already recording the session, so if someone feels uncomfortable, please feel free to leave us in any moment. First of all, I would like to take a quick look at the agenda. After this introduction, I will introduce our special speakers who will deep into the current challenges for road operators, the main technologies for connected roads that are shaping the future, and of course, the benefits and key use cases. After they talk, we will leave some space to the audience. So important message, if you have any question or doubt during the session, please feel free to write on the chat in order to keep that questions and to have the answers from our speakers at the end. And we will finish with a simple quiz with 2 questions in order to know what you think about all the topics that we are going to discuss. And finally, Bruno and Pablo, our speakers, will give us as a gift some takeaways. Without further delay, let me introduce our speakers. So I'm going to keep out my screen. And yes, here they are. Pablo Fernández Vivanco is our innovation and product manager at Openvia. And as you may know, Openvia is the technological and innovation platform of GlobalVia. GlobalVia is an international mobility operator that is specialized in highways, railways, above all in high-speed rail and buses. Welcome, Pablo.
Thank you so much.
It's a pleasure to have you here.
My pleasure.
And our second speaker is Bruno Gonçalves. He is ITS Head of Business Development Portugal at GMV. And GMV is a multinational technological group with roots in the aerospace domain, but also covering other fields such as defense, aeronautics, secure e-solutions, and of course, ITS, Intelligent Transportation Systems, where GMV addresses mobility from the public transport and automotive perspectives. Welcome, Bruno.
Thank you. Hello, everybody. Good afternoon.
So in order to break the ice, I will launch the first question. As all of you here know that the way we move around is changing every day. These changes in mobility have a direct impact on infrastructure operators, focuses on the specific case of roads that is a key business line for GlobalVia and Openvia. This question is for Pablo. Pablo, what do you consider to be the main important challenges for road operators in this sense of changing?
I'm not mute, right?
You are not mute.
We can hear you.
Classical mistake. Okay. Well, thank you for your introduction, Isabel. I think that road operators will face several challenges in the near and the long future. First of all, usual suspects, traffic congestion. Sorry, is still a problem in too many roads. The capex and opex optimization from the standpoint of the road operator, even in infrastructure elements or operational cost or something like that. and also the let's say one-way communication channel with the users. Normally, the information that we got with with operators, or speaking on behalf of the operators, the information that we gather from the users is it's very limited, and not having this kind of conversation in a bidirectional way, I think that is a challenge when also the users today and the future users want to have a voice now than never, right? Another topic I think that is really important is climate change and the impact that this has in the critical infrastructure as roads are. Okay, we here in Spain we had a perfect example of it just a few months ago in the region of Valencia with catastrophic flooding. Needs of new traffic types. We are not just having kind of manual driven gasoline vehicles. All this is changing. We have now electrical vehicles. We are going to have autonomous vehicles or more automated as the times go by, and they have some different needs, and they have some different behaviors that the traditional users that we have had during all these years in the roads. And also, I think that the business opportunity or the new concessions contracts requirements that from the public administration, my bet is that they are going to require more technification of the operation and the maintenance activities from the road operators. I think that these are more or less the challenges that we see from the road operators' point of view. I don't know about the vehicle. What are the challenges ahead for the OEMs and their suppliers, Bruno, that you see the most challenging of all?
Okay. So, for starters, the technological progress, from the automotive perspective is, in my opinion, very dependent from the path taken by the operators and by the regulatory bodies. Okay, so for me, one of the most important challenges ahead for the OEM industry, for the automotive industry, is and you also mentioned it, the full driving automation. So having automate mobility. Okay, so but onboard technology alone is simply not enough. It's simply not enough to tackle the coming of the fully autonomous vehicle. Okay, it will take not only the incorporation of precise sensors in the vehicle, but it will also require coordination with infrastructure. Okay, particularly the digitalization of the infrastructure. So sensors, cameras, all the information that you mentioned. Well, that you only have one direction communication. The infrastructure needs to evolve to become a two-way communication.
Yeah.
Okay, so this coordination will result in a fusion of infrastructure and vehicular data. Okay, and in turn, it will enable new features like precise positioning. Okay, which is it's more or less already obtainable. Okay, but it will make it easier to do. Okay, vehicle platoons, for example. Autonomous ones, okay, meaning autonomous vehicle platoons, and even features like remote driving. Okay, when there's absolutely no one in the car, but instead it's in the control room. Okay, driving vehicles from afar. Okay, and I mean, with so many data flowing, there is one big challenge to tackle, and this is by everybody. Okay, not only the OEMs, but everybody. Cybersecurity, and with it, data protection. Okay, so when we talk about cooperative systems, we must assume that these are completely open systems usable by virtually anyone. So anyone will be sending data, collecting data, and we need to to be aware that data can be stolen, and most important, data can be tampered. Okay, so this will lead to safety risks. Okay, this will lead to the disruption of the normal mobility operations. Okay, so it needs to be, I mean, I will stress throughout today the importance of cybersecurity and data protection. Okay, but I'll leave it for later too. Okay, so and autonomous driving, of course, it's very sensitive to cyber attacks. Okay, it's cars can be hacked, and not only hacked, but it can be remotely controlled by hackers, and this can be extremely disruptive and extremely a big problem for everybody's safety. Okay, so bottom line, reliable and safe communications. This is the top requirement we need to achieve together. Okay, to be able to do automated and coordinated mobility. So connectivity is probably the major challenge that we will have ahead of us, driving the digitalization of the roads. Okay, and maybe I can continue here and switch to the technologies. Okay, so when you talk about connectivity, we talk about connected vehicles and connected roads, but we talk about two key concepts here. So C-V2X, cellular V2X, and we talk also about 5G. Okay, these two already existing. There's a difference between them. Okay, so C-V2X is a communication standard. Okay, it essentially sets the rules for the communication between all actors in the mobility. Okay, so vehicles, infrastructure, pedestrians, cyclists, and others I may be forgetting at the moment. And this standard supports direct communication. Okay, so between all actors, like walkie-talkies. Okay, it's the same principle. We call this side link communication. It's basically every actor has its own C-V2X radio, and it can broadcast information, and others can collect it, and so it works this way. Okay, one important point is that it does not require a cellular network to function. Okay, so it's depending only on all the actors being able to communicate and to broadcast and share information. So 5G is an actual implementation of a cellular network. Okay, so it actually enhances cellular V2X by allowing all these actors to communicate with the network. Okay, directly, so to a centralized communication in this case, and it gives you what? A wider range of coverage. Okay, so instead of relying only on infrastructure that you deploy, like C-V2X RSUs or the onboard units in the cars, you can now rely on the 5G network that is well maintained and developed by mobile operators, telecom operators, not only by the road infrastructure operators. Okay, so, and what does this bring? 5G. It gives us low latency communications, it gives us high speed data, and so far, great reliability. Okay, so so far what we have been doing with 5G has been proven to work and to allow us to implement all these new use cases and pilots around all these new mobility features. Okay, but and now that I'm in the technology, there's also 6G coming. Okay, this one is still under research and development. It's not here yet. Okay, but it has a very high level of ambition. Okay, it aims to give us a communication channel with ultra low latency or near instantaneous latency. I think this is the correct term, and much higher speeds. We're talking about up to 100 times faster than 5G. Okay, so it's much faster and with a much lower latency. So we can get instant communication, which is, well, if we want to actually coordinate vehicles with each other and avoid crashes, I mean, this is very important. Okay. Another interesting feature about 6G is that it will integrate artificial intelligence directly in the network. Okay, so These will allow us, all these together will allow us to build things like real-time live traffic, or even HD 3D maps, or real-time digital twins. Okay, so, and one last feature before ending this 6G, okay, and moving forward, but this needs to be said, okay. The idea of 6G is to have global coverage. How? Incorporating the terrestrial infrastructure with satellite communications too. So this will allow us to have vehicular communication with infrastructure wherever we are in the world, or at least this is the goal. This is the goal. So and it's not that far away. So we can expect the first deployments of 6G by in 5 years, more or less.
Yeah.
Let's hope, if it does not get very delayed. But Pablo, tell me, what do you expect from these technologies? From
one question first. Do you see the towers that we all see in the landscape disappearing, and leveraging also the whole operation of these communications up in the air, or not?
When you say the towers, you mean the telecoms?
Yeah, telecommunication
right?
towers.
The telecoms. I don't see those going away for one simple reason. They're still the consumer market. Okay, yeah. So 6G will cater for everybody, not same as 5G. So our phones use 5G, our cars can use 5G. 6G will be the same, okay, but at a different level. I don't see that disappearing. I see satellite communications as a fallback, okay, because I at least not yet, I am not yet convinced that satellite communications will have the ultra low latency that terrestrial communications will give us, okay, and this is a point to consider.
Okay.
Yeah.
Sorry, because I interrupted you.
No, don't worry. I was going to ask you about these technologies. How will they affect the way you work? How the operators work?
Yeah, I'm going to be a little bit less technologist.
I'm sorry. I'm very,
no.
very
It's
into
fine.
technology.
It's fine. We complement each other. I like it. Yeah. I think that road operators need information to operate. Maybe it's a redundancy, and to operate and to maintain. I need or the operator needs to know what is going on with the traffic flow, what is going on with the infrastructure elements, or the most critical at least, what is going on with the weather. We mentioned that previously, and I think that the information needs a medium to flow. Okay. And normally in the concessions, the most popular deployment is optical fiber, which is cool. It's okay. But I think that wireless connectivity means ubiquity, and I think that this is a key concept of the whole thing. Traditionally speaking, road operators have, let's say, partial information, and it's gathered from a passive standpoint. I can see the cameras that I have deployed in across the road. I can have radars. I can have counters, etc. But I think that if we want to bring the operation and maintenance activity to a higher level, or to the next level, we need this ubiquity of communication in order to have as much information as possible. And what that means? I think that we need to open this. We mentioned the one way. We need to open two ways. Or a bidirectional channel of communication. I like to see like a conversation. So when two people have a conversation, they can understand each other, they can enrich each other. If you have only two separated monologues, it's not so enriching somehow. So I think that having this opening this channel of conversation with the user, with the driver that is driving through the road, or any other stakeholder. Also, our own infrastructure that has been quiet and silenced for a long time can now start speaking to the operator, telling what is my health and condition. I'm about to I don't know, to break down or something like that.
Yeah.
So connectivity, I think that for me, connectivity is kind of a way of conversation that enrich everybody. Okay, and I think that this is kind of an impact for the operators, because the whole thing, the whole telecommunication and connectivity technologies is kind of is new tech for us somehow. Even when you talk about 6G, 6G is new tech for everybody, I think. Only for telecommunication experts, but 5G is starting somehow to be deployed massively. But 6G and this communication and the new protocols involving cellular V2X or V2X in general is something new. So I think that we, the operators, the road operators, we need to understand this tech, to have the knowledge somehow, maybe not an expert knowledge, but at least at least enough information to operate, and also the potential, to see the potential that if I apply this technology, what can achieve in the future, right? And also we will have to interact with another different ecosystem of stakeholders, telcos, and manufacturers of silicon or equipment, or telecommunication equipment. Sometimes the road operator can be able or will be able to operate somehow this infrastructure as one infrastructure of themselves, right? So I think that also reskilling part of the workforce in order to know how to operate them, and how to understand the complexities of this new tech. I think that this is what is going to bring to the road operators. But I think that is not the only technology that we are going to see. We in our daily basis life, we are seeing that IoT and the most artificial intelligence are turning our lives upside down somehow. So I think that this also is affecting to all the industries. I don't know which industries are not being impacted right now with this hype of artificial intelligence, but I think that it affects to all, consumer or enterprises. And I think that we are not going to be, or the road infrastructure is not going to be the exception to the rule. It's going to come here to us, and we have to know how to handle properly. I think that IoT means that we are going to get, massively speaking, more data than the one that we have handled traditionally. We will be able to measure and to monitor all kind of things from the radars and camera. That is something more traditional for us, but sensorization, continuous sensorization of certain critical elements of our infrastructure, viaducts or something like that. Tunnels is also a critical element here in the roads. So we are going to start having a lot of information, and the only way to understand, to get insights from, to make some kind of distillation of this information that is not humanly processable or processed, is going to be with artificial intelligence. I think is going to be the perfect complement to to all the workers in a concession. I think that it should make their lives easier for all. And I don't know. I can think of some kind of examples, like for example, automatic detection of events in the on the road, for example. I don't know, something that imagine a control center where you have a lot of screens and a lot of cameras, and you cannot be seeing each other and trying to rapidly to see if an accident or an incident has happened. So rely on artificial intelligence is going to be good for us, I think. But I don't know, how do you see how these technologies, apart from the operators, can bring some added value to the drivers or the autonomous vehicles, for example?
Okay, I do believe that. I am certain that there will be added value for drivers and the automotive industry in general, but in particular the autonomous vehicle. Yes, well, as you did mention, IoT is going to be the full sensorization of roads. Okay, and it will produce massive amounts of data. Okay, this data needs to be processed into useful information. It's not just raw data. You can do nothing if you only have raw data. You need to process it. Okay, and it's massive. Okay, and being massive, it requires in my opinion, a decentralized way of processing it. So that's where, in my opinion, edge computing would come in. Okay, so we could use edge computing techniques to do, let's say, local processing of information before centralizing it in a cloud or whatever. Okay, but okay, and by its nature, okay, edge computing, functions as close as possible to the road and to the actors. Okay, this ensures latency as low as the network it's running on allows. So in case of 5G, low latency. In case of 6G, almost instantaneous latency. This is what we want to achieve. Okay, so to provide answers immediately on the spot. This is what we want based on the amount of information we may get. Okay, so one benefit that can be taken from this is for example, vehicles receiving safety alerts almost instantly. Okay, if there's a car without brakes on the road, it can warn the other cars around, and they brake or they take action. Okay, so there's this early warning to drivers and to autonomous vehicles. Okay, so but still, edge computing per se needs to be smart to process these data. So in my opinion, this is where artificial intelligence comes in. Okay, so you also mentioned the lots of information going into the control center and the operator trying to work with all that. Yeah, it's simply not possible for a human to work with so much data. Okay, so and conventional systems, traffic management systems, the classic ones, let's say, they're not yet able to handle this massive amount of data. Okay, I understand that AI is being incorporated into everything we do nowadays. Same thing is happening with traffic management systems, with fleet management systems, with well, everything, our phones, our washing machines. So but so let's get on focus. So by using AI, we can enable several use cases. Okay, both on the infrastructure side, also on board the vehicles, and together. Okay, and just to mention some already existing, for example, AID cameras that you have installed for sure in your operation, they can provide alerts using AI. Many suppliers of cameras already incorporate AI in the image processing of CCTV systems. Okay, so yeah, you can get this kind of alerts out really from cameras and from other sensors. Okay, with information from the IoT sensors and the vehicles, you can do, for example, traffic pattern analysis. This can allow you to predict congestion, can allow you as infrastructure to predict congestion, but it can also allow a vehicle to decide on alternative routes. For example, so it can do smart routing algorithms on board the vehicle, so that can optimize the travel time. Okay. Other more safety related examples, for example, to detect reckless driving situations. Let's say there's somebody drunk on the road, and you detect that there's a misbehavior pattern in the driving of a specific vehicle. You can warn other drivers, you can warn authorities. So there's so much we can do with this. And well, another example, smart speed limits, okay, based on weather conditions, on traffic conditions, on road conditions. You can set dynamic speed limits based on, well, the fusion of all this information, right?
Yeah.
So these technologies, IoT, AI, connected with, well, connected, good word, with C-V2X, okay, they will pave the way for even more use cases, okay, and I can think of a few more, okay. For example, truck platooning. Truck platooning. The basic idea is having a leading truck with multiple trucks behind them, all coordinated by the leading vehicle. Okay, so this leading vehicle can either be driven by a person, so manual driving, or it can be autonomous himself. Okay, so but this coordination needs to be very well coordinated. All the instructions, the braking instructions, the acceleration instructions, the turning instructions. This needs to be using low latency communications. Okay, so C-V2X gets in here and it does its work. Okay, in particular the side link communication I mentioned before is perfect to be used here. So the vehicles would communicate directly with each other without no middleman. Okay, so it's basically a way of improving safety, saving fuel, and even for the road operator to improve road capacity, because I mean, when you have lots of trucks, you have lots of road occupied, and then you have all the space between the trucks. When you have an autonomous platoon, the trucks are driving much closer to each other, and they brake and accelerate in coordination, so they don't crash. So you can fit more trucks in the road, basically. Then there's another scenario, remote driving. Now that we're talking about truck platoons, remote driving, you can be driving the platoon or any other vehicle, okay, from a control center, okay. So these technologies will enable this kind of use case, okay. In this situation, for example, for remote driving, you will have video feeds, real-time video feeds, and you need to be able to send instantaneous commands to control the vehicle, okay. So I mean, again, we need low latency, we need instant communication, high bandwidth for all these to work. Okay.
Yeah.
One other example could be for emergency situations. For example, imagine you pass out while driving. In the future, when your car is autonomous and can make calls by himself and so on. So imagine you pass out, your car stops, call the emergency services. An operator picks the call, understands you are not responding, but the car told you, using, I don't know, in-cabin sensors, for example, it told the emergency services that you are in distress. So imagine if if the operator can drive you to the near hospital remotely.
Yeah.
Okay? Instead of having to wait for an ambulance. So I mean, there are a lot of use cases here that could be applied. Okay, but from your perspective, Pablo, what are the key use cases you could consider?
Yeah, I think that many of them you have some kind of mentioned before, but I think that all what is related with delivery of information from the whole context of the road and the traffic flow directly in vehicle in order to for the autonomous driving control unit or the human that is driving. It's very important in order to make the driving safer for all, I think. But also the other way, we can imagine a future where all the vehicles can send information about the road condition as they drive to the operators, making the maintenance activities more efficient. For example, tolling. We can let's say think of new ways of tolling with with less infrastructure involved, less maintenance. For example, we can imagine road user charging. We can imagine managed lanes where the tolling is more precisely applied somehow, and this needs accuracy for the vehicles in order to give a precise location or high accuracy location to the operator, and this support to the GPS, for example, can be coming also from the road operator, for example. Also, you mentioned before massive sensorization of the infrastructure or critical elements of it. This will have some derivatives like having a model in digital twin where you can see all what is happening in the elements of your infrastructure, or you can go and achieve, for example, predictive maintenance in order to make everything in your operations more optimized from the point of view of cost, for example. You can also make a greater automation of O&M, internal processes. Like, for example, I mentioned before, you can have a multi-source, not only from your camera, also from waste, for example. Event detection, automatic event detection, or you can have a better flow in your customer service processes. For example, if you are able to automate, if you can have some automation of the process, right? And I think that you mentioned this direct communication between vehicles, between the trucks or the vehicles.
Sidelink, yes.
Yeah, we can use this also in order when the, let's say, the workers, the field workers are carrying out some kind of task, fixing something, pothole or something, we can increase the road safety level in that part of in that stretch of the road, enabling a direct communication with the coming traffic. Hey guys, I'm working here. Just relax, lower your speed or something like that, right? And I think you mentioned the platoon use case. And I think we can even dream bigger. And why not a scenario in the very in the long-term future, where the road operator can orchestrate. Imagine the whole vehicles amount of vehicles are automated. The road operator, who is the one that knows perfectly or have the most information of every stakeholder of the whole road, can make the flows more efficient in terms of sustainability or environmental sustainability, in order to make more efficient flows in the road. All these use cases are things that we are here in Openvia. We are trying to gather in the near road initiatives. We are at the beginning of the whole thing, but why not, as I mentioned before, dream bigger, right? And I think that, I don't know if we have time for this, Isabel, or we are a little bit in a hurry.
So we are, we have 50 minutes.
Okay,
15,
I'm going to. I think that the benefits, just to mention benefits, we mentioned challenges, but benefits for operators come from much more efficient and more sustainable operation and maintenance activities for all. We are trying to increase the road safety for all, not only for the drivers, but also for the people that is in the surroundings of the road or working on the road, right? Shorter response time, in case of unforeseen events from the operator's perspective, and increase operators' competitive advantage when new concessions come in the future, right? And or not only concessions, but maybe also some other kind of new business model or new revenue streams that the operator can catch. I don't know which is your opinion here of the benefits, what the O&M have to gain from these innovations, or what do you think can be the biggest benefits for all?
Okay, I'll try to summarize since we don't have much time. But okay, a lot has already been said. Okay, so but OEMs will also need to adapt. Okay, it's not only the infrastructure that needs to evolve; it's also the OEMs that will need to accompany this evolution. This will come as an opportunity to implement new business models. Okay, just to give a quick example. A vehicle which is almost practically a software platform nowadays, and even more in the future, it can receive new features over the air. Okay, like over the air updates, adding new features or cutting features to the vehicle. We are already seeing these kind of features appearing. Another opportunity for the OEMs is the monetization of vehicle data. Okay, so there is a lot that can be explored with this new data set that is going to be available for OEMs, for governments, for operators. Okay, but on the challenges side, I want to stress again the cybersecurity. Okay, I mean it's really important, because if the systems are not secure enough, we're going to have a public acceptance problem. It's as simple as everything is going fine, we are deploying everything, doing great dissemination, and suddenly an autonomous vehicle is hacked, it runs over people, crashes into other cars, and this is all over the news, and public acceptance goes down. So, I mean, we need to really take care of how we deploy these, think very well how we're going to do it, and, well, OEMs can't do it alone. So cybersecurity is on both ends of the communication channel. So we really need to take this into consideration. Okay. Another challenge for me is global standardization. Okay, there are a lot of standards that the automotive must support, depending on the region they are sold. Okay, we have the EU standards for V2X. We have the US standards for V2X. Okay, why not have one global standard, and that's it? Okay, I think it would ease the work of everybody. Okay.
No, totally.
Yeah, but okay. In general terms, this is it.
Okay, so thank you, Bruno and Pablo, for such interesting and inspiring talk. Thank you for giving us as well the benefits, because it is important for the quiz. After that, and you have talked about different technologies. However, 5G and 6G have aroused a lot of interest in our audience. We have some questions on the chat, so we don't have enough time to answer everything, but I will launch two. Okay. Regarding AI as well. Maria Luisa Garcia says, nowadays we have cameras with AI and 6G offers AI as well. However, we can transmit the information from our cameras through 5G. So in this case, what is the difference between having 5G and 6G? Bruno?
Okay, I can answer this one. Yes, okay. I can. Okay, so Okay, yes, nowadays we do have cameras with AI. I actually mentioned that during the webinar, and we can transmit that information through 5G. It's true, but the big difference between 5G and 6G here is that AI in 5G AI is incorporated at the application level. So in this case, it's incorporated in the cameras, processed there, and then the result of this processing is sent via the network. And the network is always the same. In 6G, AI is incorporated into the network itself, not just the application layer. Okay, what does this mean? It means that, for example, imagine I will give a practical scenario, so to make it easier to explain. Imagine there's an accident, okay, and the system knows there's an accident in that specific spot. So the network itself will be able to look at traffic conditions, network conditions, alerts and emergencies on a specific site to prioritize and optimize the network for that specific location. So to reduce latency and to provide higher bandwidth. So this is how AI is going to work in 6G at all levels, not only application.
So 6G gives us better latency?
6G is supposed to come with much better latency, almost instantaneous.
Okay, this is the answer, Maria Luisa, because you were a little confused. Pablo, does 5G is enough matter in mobility industry and cars integration to start thinking about 6G?
Yeah, this is, I think, a tricky question. Thank you, Alessandro. Yeah, I think that most of the consumer devices have already this kind of things. I think that also from the perspective of the telecommunication operators, going to a 5G standalone that is like the real 5G is also coming and quite extent in some countries more than in others. But I think that we are still in the adoption phase somehow. At least talking about more automotive industry, putting us in the infrastructure operators also in that bag, in the automotive industry thing. Because, for example, and this is just one grasp of the whole thing, depending on the geography, depending on the OEM, we are still fighting friendly speaking, between the DCRR, that is one, maybe here Bruno can extend the information, but it's some kind of one kind of protocol, communication protocol, and the other thing is, or the other protocol is the cellular V2X, that is more relying on cellular as the 3GPP standards. So there is not let's say homogeneous adoption of the whole thing. There are technologies that are being selected from one part of the ecosystem and one from another. So it's too soon to start talking about 6G. Sorry. Maybe for us, yes. Maybe for the whole of all the industry. Sorry. Maybe it's time to start talking, at least to start seeing which is the way that this is going to take. But I think that it happens in the world of technology. I think that in telecom also, technology is always the same. We are starting to adopt some technology, and 1 week after, we are start hearing from the new generation of the whole thing, of the new technology. So it's I think that it's something that has been that's been happening all the time. So I think that we are not to be afraid of that.
Yeah, it's true, Pablo. Thank you.
Mhm.
So we have more questions, but we just have five minutes. So I would like to know the opinion of the audience. So please, you can follow the link on the chat to open the quiz, or you can as well scan the QR code that is shown in the screen. Can you see my screen?
Yep.
Okay. So let's start. Please scan the QR code or follow the link on the chat. We have just two simple questions. The first one is about the technologies introduced, the 4 technologies. And let's see what think the audience. Which one do you believe will most revolutionize the roads of the future? And the second question is regarding the benefits. So thank you, Pablo and Bruno, to talk about the benefits as well at the end, because this is a tricky question. Which one do you consider the one that impacts people's lives most? So I think that lower response time from emergency services in case of accident is the winner regarding safety.
For now.
No? What do you think?
It's a tie,
Yeah.
but both are related to accidents.
Yeah. So the safety is the most important part for all of us. And in the first question, AI. AI is the winner. Yes. However, the questions were related to the 5G and 6G technology.
And AI
So
also and IoT. So yeah.
yeah, it's true. It's true. It's true. So we have 19 answers. Yeah, more or less. We can assume the main responses, no? The winners. So that's it. I am not receiving more answers. So as we have little time to finish, I would like to ask you, both of you, some takeaways, like slogans for the audience, to keep in mind the main ideas, the main claims, the main takeaways to go home. So please,
Bruno.
Pablo.
I can
Bruno.
go.
Yeah.
Okay.
Okay, I can. Okay. So takeaway from this very interesting conversation, I would say that the technology to transform the road mobility is already here. Okay, we already have 5G. We'll have more in the 6G is an evolution. Okay, but it's already here. But its true impact depends on how we will implement it and standardize it. Okay, harmonization of the standards is very important. So collaboration among all stakeholders is essential to ensure seamless interoperability across countries and on the OEMs. Okay, so by aligning on key technologies, defining global standards, and prioritizing real world use cases, we can pave the way for safer, smarter, and more connected roads. Pablo.
Yeah. my takeaway is that talking about smart road or more technology in the roads or something like that can be seen as a challenge, sometimes even as something hard to swallow. But I think that the perspective should be that seeing this like a door that opens to a lot of opportunities, also for road operators, not only for the rest of the ecosystem. And it is going to require the financial investment, knowledge investment, but sooner or later, I think that it will be a good investment. It will get a very good return of this investment. So embracing connectivity or AI or IoT or the rest of the technologies that we have mentioned will allow road operators, especially to keep a seat at the table in the conversation with the rest of the stakeholders within the ecosystem. And I think that this is not a chance that we should miss, to be honest.
Good.
That's all.
Good. Yeah, that's all. 4 o'clock record time. So thank you, both of you.
Welcome.
Thank you very much for all the people that is here, for the audience, for their interest. And please stay tuned, because we are going to launch the 3rd webinar very soon. I don't know when, but very soon. Bruno, Pablo, thank you.
It's been a pleasure.
Thank you.
Thank you, Bruno.
Gracias. Thank you. Obrigado.
Bye-bye.